Hi, welcome to this video. And now I am talking about today is concrete and steel. So first of all, we know what is first of all we know what is steel. So where steel is an alloy of iron with typically a few tenths of a percent of carbon to improve its strength and fracture resistance compared to iron. Like uh, we see here two iron atoms and two more iron atoms and which divides of two iron atoms between is carbon atoms, right? So this is called a steel. Steel is a alloy of iron with typically tens of 8 percentage. Now we are seeing like this type of steel, and this bar which tends to the upper surface is called lug, and lower surface is called rib, and front surface is called bar bar front view. Once bar side view is like this. Okay, then next I am talking about a steel. First of all, we discuss mild steel. Mild steel is the combination of iron and steel. Iron not carbon, sorry. Iron not carbon. Iron presence in 98% and carbon presence in mild steel is 0.05 to 0.25%. And stainless steel contain less than 1.2% of carbon content. Alloy steels contain variety of elements of elements in which carbon content is 0.1 to 1% depending on this type. We have seen this type of mild steel, and next is discussed carbon content in steel. Carbon content in steel, and we are seeing the brokenness, the hardness, the longitudeness. The carbon increases hardness and strength. We are talking carbon content in steel. Carbon we have like increases hardness, steels decreases visibility, ductility. Okay, and then basic mill products, plates, bars, and sections like I, C, and L, like this type of. Then common type of structural skill we are discussing. Mild steel. We are discussing previously. Mild steel is the combination of carbon and steel. Carbon presence is 98% and steel presence 0.05 to 0.25%. Then we are discussing now here mild steel, carbon steels. 90% of steel is this type. Is a stiff and strong, has magnetic properties. Its properties is magnetic properties and is highly corrosive. Highly corrosive. Then talking stainless steel now, add 11% chromium does not stain corrode. Have 11 different grades. Examples, uh 301 to 316. Okay, and etc. Now we are discussing structural sections, iodized beams. We are seeing here wave wave like wave like this wave like this, and flank like this, this wave is the vertical member. This is the vertical member, and the flank is two horizontal elements we are discussing, and classified as wave was classified as ISLB, ISMB, ISHB, and ISWB. Okay, next discussing next one is of T. Structure section of T type, and there we are discussing waves, flanks, then T types. Then structure sections T. The T beam is best utilized as a load bearing beam. Allow for large loads to be carried appropriately. We are seeing here we are carried out T shape of structure section is appropriately. And next one is I am discussing, and now I'm talking structure section L angles. L angles we are seeing everywhere, and we have used construction and buildings and over steel bridges. We are uses these types of steels, right? L angles. L angles are of two types: equal angles and unequal angles. Equal angles and unequal angles. We are seeing IS have A specified size, thickness, and weight are for each, commonly used for framed buildings, trusses, and fencing. Now, I am sending and I'm speaking L angles, and this type of steel are used to commonly used for buildings, constructions, and roof trusses and fencing. Now I'm discussing roll angle section. Roll angle section. Angle section are widely used for roof truss construction and for filler joints, joist floors. Equal angle sections are available from 20 mm, 20 mm into 3 mm. Three thicknesses 20 mm, 20 mm into 3 mm. 220 mm, 200 mm, 200 mm into 25 mm with their corresponding weight. Weight as 9 Newton and 736 Newton, 736 Newton per meter length respectively. Unequal angle sections are available from 30 mm, 20 mm into 3 mm like this per meter unit length. We are discussing per unit per meter length, Newton per meter length. Okay. And the next one is discussed. Next one is discussed structures sections. Structure section plates of steels. Okay, plates are a wider form of flat sheet, generally used to connect built up girders, beams, columns, and also used as tension members of steel ropes, trusses, and base plates. And the next one is structural shapes bars. Steel bars have a differs range of application in a variety of industries. Application depends on shape and size of steel rods. And generally, these are two types of bar available in the market. Rods, types of bars, mild steel bars, deformed bar. Right. We are seeing here down to a steel bar which are plain without ridges, and HYSDB steel bar which have ridges and more yield strength. Okay. Then we are discussed the first TMT bars. TMT bars are manufactured to the craft soft core, and we are discussing and we are seeing here. See here TMT bars. Okay, and TMT bars are manufactured to the create a soft core and top exterior in the ribbed bars. It allows the bars of again more yield strength and the elongation. TMT bars are widely used. TMT bars are used widely. Okay, TMT bar theoretic thermomechanical treated bar. Thermomechanical treated bar. Okay, then we are discussing its nature, its characteristics, right, and its behavior. Better ductility and malleability, high yield strength and toughness, more building strength, more earthquake resistance. It's TMT bars, and each of it has mainly used building construction, and this we are suffering and we are safely this type of properties, right? More building strength, more earthquake resistance, more corrosion resistance, more thermal resistance, economical and safe, more well availability, more durability, and we are discussing see here thermomechanical treated bar, right? And this is deep since outer in this core in the main course of the between parts. And now discussed mild steel bar. Mild steel bar plain and round in shape. This shape is plain and round in shape. 6 mm to 50 mm available used for if for expansion joint contraction joint runway column spiral cut and bend without damage. No great bonding between concrete and steel, less strength it's have. Now the next one is HYSD bar, meaning high yield strength deformed bar, and we are discussed reeve. Then the rods rods mainly both of but top to bottom of path, top to bottom of see here this reefs called. High strength deformed bars are called twisted steel bars. Superior bonding strength, good welding capability, high tensile strength, and high tensile strength, satisfactory malleability. And the next is TMX bar, Thermax technology, Tamcrop technology, and TMX uses of these types of rods. It has low carbon percentage, better ductility nature, and better elongation nature, and better yield ability and bend, welding and bending, right? Ability, better heat and fire resistance, more ribs provide more grip and more long life. It has. I'm discussing TMX bar. Life of TMX bar, which types of natures, and elongation, propagation, and hits are fire and and all. And the next one is CRS and SD bar. CRS corrosion resistance steel manufactured by an addition of copper and chromium. ST superductile. Superductile, it offers more energy absorption capacity to the building structure and therefore a higher evacuation time in cause of earthquakes. ERS and ST bar. Yeah. And the next one is structural steel building. Now I am discussing structural steel building. We has proper use as a usage of factory, more type of transportation, factory, car factory, different types of factories. We have used to steel structure buildings and steel structure construction, and steel structure bridges are used to more highways. Okay, then a structure which is made from organized combination of structural steel members. Structural steel, what is structural steel? Is a structure which is made from organized combination of structural steel members, and we have see here these types of structural steel like shape. Let's see here. Okay, like this. And next one to discuss the structural steel building advantage. What is the advantage of a structural steel? What is the advantage of a structural steel building? We have see here a very steep in respect to their cross section area, can support a high load without excessive sagging, can have longer span members than RCC. We have see here structural steel building. Okay. Now advantage of a steel structure. We are discussing advantage of a steel structure. It has highest input mass, have even for long structures. The size of a steel structure element is small, saving space in construction. It has assured quality and high durability. And steel structures can be strengthening at any time if necessary. It needs just welding additional sections by using bolted connection. Steel structures can be easily dismantled and transported to other sites quickly. It is water and gas resistant structure, hence can be used for making water tanks also. Material is reusable. Disadvantage of steel structure we are seeing here. It is susceptible of to corrosion. Corrosion maintenance cost is high since it needs painting to prevent corrosion. And we have see here these types of skills, and previous we are discussing the advantages of these types of skill we have see here. Okay, and we have steel structures combinations, steel structure types of combination we have used to steel structure. And now reinforcement is a steel bar of different diameter and grades, and good strength for economic design of RCC structure. And it has the RCC mainly this type of recognition, and this RCC which have uses here. Okay, good strength for economic design of RCC structure, good resistance against corrosion for higher durability, good gripping or good bonding with concrete. Okay. Then now coefficient of thermal expansion. The coefficient of thermal expansion describes how the size of an object change with a change in temperature, specifically it measured the fractional change in size per degree change in temperature at constant pressure. Okay. The coefficient of thermal expansion. Okay. The coefficient of thermal expansion describes how the size of an object changes with a change in temperature. Specifically, it measures the fractional range in fractional change in size per degree change in temperature at a constant pressure. Coefficient of thermal expansion is 1.2 into 10 raised to 5 per degree Celsius. And you see as a compression and tension when a beam or a slab or any concrete structure experiences bending moments due to bending moment in the structure, compression and tension develops. Concrete resist compression due to its high compressive strength, but it cannot resist tension. So the resist this developed tensions. This is reinforcement system but is provided. Okay, we are seeing here these properties which are when we have used the slabs concrete and structure compression and tension concrete due to its high compressive strength, but it cannot resist tension. So we have used to reinforcement cement reinforcement steel bar. Okay, then we have you see here compression tension, and then you have applied the two folds. The other side we applied to a stretching, then compression tension, then applying load. We have see here these types of phenomena. And thank you so much. Thanks for watching this video. And I am I thank you so much watching this video. Thank you so much. Thank you.